The last video cut off when I was saying that you needed to be careful when you're comparing and contrasting the X bars, the means from a specific number of trials, for example, the 0.5 out of these 4 trials or the 1 out of the 5, when you're comparing those X bars to the mu sub x's, the theoretical means. So let's go back to our textbook. Your textbook explains this in another example where it looks at 100 values for free throw shots. So they give you another X bar, this time one that's closer to our mean, our theoretical mean. And what you want to keep in mind is that if you do a small number of trials, like 4, and you get 0 out of 3 of them and 1 on one of them, like we were looking, or excuse me, 2 on one of them, like we were looking at here, this creates a number that's much smaller than your theoretical mean of 2.4. But if your player does 100 trials, you should expect that the average of those 100 is much, much closer to the theoretical mean, and that difference between the two would decrease the more number of trials you do. So in other words, if your player did 500 free throws, you would expect his average to be pretty close to his theoretical average, and I would be pretty surprised if we were getting an average of 0.5 or 1 out of that many of trials. That might indicate that our player might not match up with our theoretical distribution. So keep in mind, we're going to be kind of investigating this idea of a small trial to a theoretical average as we go forward. And in fact, your book introduces one other piece of notation, which is expected value. You'll see this written as E of x. So this E of x, let me navigate back here, this expected value, E of x, is another name for the theoretical mean. So you'll see that sometimes we ask you, what is the mean of the random variable? Or what is the theoretical mean? Other times I'll say, what is the expected value? You want to think about those two terms as interchangeable. And in fact, your book reminds you, hey, it's exactly the same. Now, in this case, expected value is oftentimes used in the context of insurance policies, or we'll also see some gambling examples in 6.1 where we ask the expected value of a game, maybe where you're playing roulette or something else where you're gambling, or the expected value of a life insurance policy. So our context changes a little bit, but you still have to build a table and calculate a mean or an expected value. So what I want to do is just walk through a little bit of this life insurance example and show you how to use StatCrunch with it, but I also want you to read through it and make sure you understand how to do it by hand. So typically in these problems, they'll give you a paragraph description. Again, a lot of times with life insurance, other times with some sort of dice or roulette game where they describe the scenario and you have to build the table. So your first step in these problems is to take this paragraph and translate it to a table like they did in Table 5. That's the tough part. Once you can figure out the outcomes, in the life insurance example, your person could survive or die, and the associated probabilities, which are usually embedded somewhere in the problem, you can take this information and put it into StatCrunch. Once you do that, StatCrunch can spit out the expected value or the mean, but you can also do it by hand. So I'm going to leave the part to you of reading through this example and understanding how they build this table. What I want to do is type this table into StatCrunch and make sure we can ask StatCrunch to give us this value. So let's go ahead and ask StatCrunch to do a new data table. And I'm going to type in my X values, which in this case, the X values are the amount of money gained or lost, think about it as a payout, to the insurance company. So they can either gain $350 from the policy or they can lose almost $250,000. So make sure we get this right, $249,650. And then we'll put in these probabilities. And then keep in mind, if you have two mutually exclusive outcomes of someone surviving or dying in an insurance policy, you want to think about complementary events. The sum of the probabilities in your second column has to equal 1. So we could just do 1 minus our probability of surviving. And in this case, we do want to keep all of those decimal places. So just double check these. And then once you have this information into StatCrunch, you can ask StatCrunch to build a picture. Calculators, custom. Notice I didn't even input anything into my column headers. And you have some issues with the picture here. It's not as helpful when you have values of X that are a little positive and very, very negative. StatCrunch kind of doesn't know what to do here. Notice that graph isn't helpful, but notice it does produce for us a mean of the 84.25, which should match what we did by hand or what the book did by hand. So again, what I want you to do is read through this example. Make sure you understand the setup. That is the hard part in this case. But once you have the setup, you have two options. Expected value is mean, which you can calculate using the by hand formula of multiplying your x's by your probabilities and adding them. In this case, it's really quick since you have 2 rows. But I also want you to know that you can do the same thing in StatCrunch. Most of the time for the expected value problems, they're just asking for the expected value or the mean, and not the standard deviation. But if they did, you certainly have the standard deviation in StatCrunch. Notice it's a really large number because our outcomes are also spread apart as well. So that one doesn't have a good interpretation, but I do want you to read through your interpretations of what this 84.25 means. So we're going to end this video there and take a look at 6.2 in our next video.